Okay, hello, grade 12. In today's lesson, we're going to be looking at Doppler effect. And without any further ado, let's just get right down to the questions. So we have question 6. It says an ambulance with its siren emitting sound of a certain constant frequency approaches an accident scene at a constant velocity. A stationary sound detector at the accident scene records a frequency that is 2% higher than the actual frequency of the siren. Then 6.1 says state the Doppler effect in words. So let's run quickly to that. So Doppler effect, we say, is the apparent change in the observed frequency as a result of the relative motion between the source and the observer. So that's how we are expected to define it for 2 marks according to your CAPS document. Then 6.2 says explain why the detector records a higher frequency. So to explain that for 2 marks, we say as the ambulance approaches towards the sound detector, the sound waves from its siren become compressed and thus the frequency emitted is higher. So this is the situation that we have here. As the ambulance is approaching, what is happening to our wavelength? The wavelength is becoming shorter. In other words, it is becoming compressed, right? So we know that according to our formula, we know that the wavelength is inversely proportional to the frequency. So the shorter the wavelength, the higher the frequency. So this is what is happening here. Then 6.3 says calculate the speed of the ambulance, then take the velocity of sound as 343 meters per second. So now this is a note to you learners that you shouldn't always memorize that the velocity will always be given as 340. So sometimes they do change it, and then as with this case we are given 343. So take note of that. Now to answer that, we have a case whereby we are told that the source which is emitting the frequency is moving towards the detector or the listener. So we know that we will have our formula like this. So if it is towards, we know that if it is moving towards, then our positive has to be on the numerator and the negative on the denominator. So we have V plus VL over V minus VS, and then all that multiplied by the frequency of the source. Now we are told that the frequency of the listener, meaning the detected frequency, is 2% higher than the frequency of the source. So to represent 2% higher, let's first look at the frequency of the source. The frequency of the source represents 100% of the frequency. But now if they say the frequency of the listener is 2% higher than that, that means the frequency of the listener represents 102% of the frequency of the source, right? Because it is 2% higher than the frequency of the source, meaning that expressing this, we have 100 over 102 over 100, because that's 102%. So remember, anything that is a percentage is expressed over 100, then multiply by fs, which obviously this will give us 1.02 fs, right? So we have our fs as being 100%, so that's 100 over 100, which is just 1. So we can just express fs as fs, but the frequency of the listener will now be expressed in terms of the frequency of the source, which will give us 1.02 fs, representing that it is 2% higher than the frequency of the source. That's 102%. So now we will change this one because we want to work with the same variable. So you can see in this case we are not given the frequency of the source, and then we do not know that we are not given the frequency of the source, we are not given the velocity of the source, and we are not given the frequency of the listener. So we should at least work with the same expression here. So it's 1.02. So it's 1.02 fs, and then this will be equal to, the v here is a constant of 343 as given on the statement. Then the frequency of the velocity of the listener, meant to say, is 0, because now the sound detector, it is said to be stationary, and then 343 minus the velocity of the source. then multiply that by the frequency of the source. So now we have all this expressed in the frequency of the source, meaning we can now cancel out the frequency of the source by multiplying by 1 times 1 over fs both sides. So now it will just cancel out the fs. So you do your maths there. Then here we'll be left with 1.02, and then that will be equal to 343 over 343 minus Vs. Now at this point we understand that we just have to cross multiply this, so this is over 1. Cross multiply here, we'll have 1.02, and then in brackets 343 minus Vs is equals to 1 times this is 343. Right, then at this point we can just multiply inside with this 1.02. So we have 1.02 multiplied by 343. This will give us 349.86, and then minus 1.02 Vs, and then is equals to 343. This point I can take this one because it is negative, transpose it to the right hand side, take the 343, transpose it to the left hand side, so we have 349.86, and then subtract 343, and then this will be equals to 1.02 Vs. Then what do we get from here? Let's just continue this side. Then we will get a 6 point, from subtracting 6.86 is equals to 1.02 Vs. Then we understand that we have to divide both sides by 1.02, so 1.02, and then our Vs will now be equals to 6.73 meters per second. Right, and that's our solution. Awesome. 6.4, it says the frequency of the sound emitted by the siren is 720 Hz. Calculate the wavelength of the siren's sound. So we are given the velocity, the frequency there, and then we are required to calculate the wavelength of the siren sound. But remember, we already have the velocity from the above question. This is 343. So this is the velocity of the sound, because we are calculating the frequency of the sound. So to calculate that, it's only for 3 marks. We need the formula V is equals to F times lambda, and then the V is 343. So we have 343, and then this is 720, and then lambda here, so we can divide both sides by 720, and then our wavelength will now be 0.48 meters rounded off to 2 decimal places. So yep. Then 6.5 says state one use of Doppler flow meter. So understand that it is saying Doppler flow meter, so we must give the use of a Doppler flow meter, not that we must give the use of the Doppler effect. So it's the Doppler flow meter. The Doppler flow meter measures the blood flow. Okay, so we have another question 6. It says a police car is moving at a constant speed on a straight horizontal road. The siren of the car emits sound of constant frequency. And then it says each of 2 observers A and B standing some distance apart on the same side of the road records the frequency of the detected sound. Observer A records a frequency of 690 Hz. And observer B records a frequency of 610 Hz. Then this is observer A, this is observer B. 6.1 says state the Doppler effect in weights. So again, Doppler effect is the apparent change in the observed frequency as a result of the relative motion between the source and the observer. Then 6.2 says in which direction is the car moving? Choose from towards A or away from A. Give a reason for the answer. Since here we are told that observer A records a frequency of 690 Hz and observer B records a frequency of 610 Hz, we know that when the sound source is moving towards a listener or an observer, a higher frequency will be detected, and when it's moving away, a lower frequency will be detected. So as seeing that observer A is recording a higher frequency, we can safely say the answer is towards A. Why? Because the higher frequency is detected by observer A. Then 6.3 says determine the speed of the police car. Take the speed of sound in air as 340 meters per second. So with this one, we can see this is a case whereby we have to solve this simultaneously. You can see with the marks, it's 6 marks. And then also that we are not given anything on the frequency of the source, but then we have 2 observed frequencies, right? So we have 2 objects involved in here, 2 observers involved. That means this is a case whereby we have one whereby it's moving towards, as we have confirmed in the previous question, and then it's now moving away from observer B. So the police car is moving towards A, but moving away from observer B. Then, okay, to calculate that, we will need to express these 2 scenarios. So the first one with towards A. So for towards A, we will say this is frequency of the listener is equals to V plus VL over V minus Vs. So we know with towards, the positive is on the numerator and the negative on the denominator. So multiply that by Fs. Then okay, the frequency of the listener there of observer A is 690. So this is the frequency detected by observer A. And then we have our velocity as 340. Then we are told that the observer A is just standing on the side of the road, so its velocity is 0. Then here we have 340 minus Vs. So we are not told of the velocity of the source, then we are not told of the frequency of the source. So this is the expression that we have. Then cross multiplying here, we will end up with 690 bracket 340 minus Vs is equals to 340 Fs. So let's express this as our equation 1. Then we have another case here whereby it's now moving away from A. So away from A, this is away from B, and to say, so where it's moving away from B, and then we have FL is equals to, so we have frequency of the listener is equals to V, and then this will be minus VL, because remember, when it's moving away, the negative is on the numerator and the positive on the denominator. Then Vs, and then multiply that by the frequency of the source. So the frequency detected by B is 610, since it's moving away, and then the velocity there is 340 minus 0, because observer B is also standing on the side of the road. Then here we have 340 plus Vs, and then multiply that by the frequency of the source, which we are not told. So to cross multiply here, we will have 610, then in brackets 340 plus Vs is equals to 340 Fs. Then let's say this is our equation 2. Now we can see that both equation 1 and 2 have the same subject of the formula, which is this 340 Fs, right? So, okay, we can now choose to equate these 2 equations, since they have the same, they're expressed into the same variable, or the same subject of the formula. So we can say equate equation 1 and equation 2, right? So that means we're going to take this whole expression here and equate it to this expression. So we have 690, and then in brackets 340 minus Vs is equals to 610 340 plus Vs. Then obviously you have to do the math here. Multiply inside the brackets with 690. So we'll have 234 234,600, and then minus 690 Vs, and then here when we multiply the 610 into the bracket, we will have 207,400, and then plus 610 Vs. At this point, we can just take the Vs to one side. So take this negative 690 to the right hand side and take this 207,400 to the left hand side. So we'll have 234,600 minus 207,400 is equals to 610 Vs plus 690 Vs. Then allow me to just continue here. So when we subtract this, we'll end up with 27,200. So 27,200, and then is equals to 1,300 when we add that Vs. Then divide both sides by 1,300. And then our Vs will be 20 point. So we have 20.92 meters per second. Awesome. And then 6.4 says name one application of the Doppler effect. So you can just say it's to detect the heartbeat of a fetus or any other function of the Doppler effect that you know. Okay, let's look at the last question here. So we have question 6. It says the siren of a train moving at a constant speed along a straight horizontal track emits sound with a constant frequency. A detector placed next to the track records the frequency of the sound waves. The results obtained are as shown in the graph below. Then 6.1 says state the Doppler effect in words. So again, we can see how important that formula is. It is always the first question. So I'm doing all these questions because I want you to see the trend of questions. And then it makes it easier when you practice. You get to know what is required of you when dealing with each and every topic. So let's run quickly to that. It says Doppler effect is the apparent change in the observed frequency as a result of the relative motion between the source and the observer. So that's how you're expected to define it. Then 6.2 says, does the detector record the frequency of 3,148 Hz when the train moves towards the detector or away from the detector? So as we can see here in this graph, we are given two frequencies, right? One is higher and the one is lower. So now they want to know, is this frequency 3,148 recorded when the train is moving towards the detector or away from the detector? Now we already know that when a sound source is moving towards a particular detector, a higher frequency will be recorded. So that means our answer there is towards, right? It is moving towards the detector. Then 6.3 says, calculate the speed of the train. Take the speed of the sound in air as 340 meters per second. So we are given again as 340, but remember I told you do not always memorize that it will be 340. It is best that you read the question and use the value that you will be given there. Then okay, 6.3, to answer that one, we can also see again, because we are given two observed frequencies here, that this will be a simultaneous type question. And then also the marks here are speaking with us. So this is 6 marks. So you know when it's 6 marks, it's probably a simultaneous question. And then you can also identify that when you are given two observed frequencies, right? So we have two frequencies, one when it is moving towards and one when it is moving away. Then okay, let's calculate. So let's start with the scenario of it moving towards, right? So the train moving towards. So we know when the train is moving towards, our formula becomes FL, and the positive is on the numerator. So plus VL over V minus Vs. So the minus is on the denominator and the positive is on the numerator. So we have it like that. Let me just write this one nicely. Okay, and then V. So now let's substitute the frequency of the listener when it is what we have that 3148 and is equals to, here we have the 340, but the listener is just stationary, so we have 0, so the detector is just stationary, and then 340 minus a Vs, which we don't have, and then also the Fs that we don't have. So you will see that this question is quite similar to the one that we just dealt with previously in the second question. So okay, so we have 3,148. So I always say that with maths and physics, the concept is always the same. What they will do is just change numbers. So you can see this proves my theory. Then we have this one as equation number 1. And then let's check now when it's moving away. Let's see when the train is moving away. Our formula is now FL is equals to V minus VL. So remember, away the negative is on the numerator and the positive on the denominator. Then we have it like that. So frequency of the listener is 2073, and then here we have our 340 as given on the question minus 0, and then 340 plus Vs, and then we have our Fs again. Then cross multiply this, we will have 2073, then in brackets 340 plus Vs, then this will give us 340 Fs. So we'll express this as our equation number 2. Then at this point we can see that both these expressions are expressed in the form of 340 Fs. So we have 340 Fs being the subject of the formula rather. So we can just equate the two. So we'll say equate equation number 1 and equation number 2. Right. So now we take this expression here, 3148, and then 340 minus Vs is equals to 2073, 340 plus Vs, right? So at this point, you just want to do your maths. So PT, there are no marks for what we are going to do right now because in physics, they don't really care about your maths. So let's do our maths here. We have this, multiplying this, we have 1,070,320, and then minus 3,148 Vs. When we multiply this one, it gives us 704,820, and then plus 2,073 Vs, right? Then we know the drill. Bring everything that has Vs on the right hand side and then take this one, transpose it to the left hand side. So we have 1,070,320 minus 704,820 is equals to 2,073 Vs plus 3,148 Vs, right? Then let me continue here. So this will give us 365,550, and then is equals to 5,221 Vs, and then divide both sides by 5,221. Then also here 5,221. Then the Vs will be 70.02 meters per second. Right. So it is quite a long process to do all this. Okay, so now we have 6.4. It says the detector started recording the frequency of the moving train's siren when the train was 350 meters away. Calculate time t indicated on the graph for 2 marks. So in order to get time t, we know that if we make use of what we learned back then, maybe in grade 8, we have distance, speed, time. So we know that if we want the time, we simply say distance over speed, right? Then we are given the distance here. It's 350 meters, right? And then what is our speed? The speed is what we just calculated in 6.3. And then remember, we got our speed or our velocity as 70.02 meters per second, right? Then we can just use that to calculate. So let's run quickly. So we have time will be expressed as distance over speed, or you can simply express it like this: change in t is equals to delta x over your velocity. So this is delta t is equals to change in x, which is your distance, is equals to 350. And then what is your velocity? Is the one that you calculated above. So you have 70.02. So calculating that, we have 4.9985, which is approximately delta t is just, and just say it's 5 seconds, right? So if we just round it off to the whole number, then it's just 5 seconds. Awesome.